Welcome to module number 3 on VLANs. We titled this module 3 as lesson number 3, and this is when we start to look at virtual local area networks. Generally, the overview of the main objective of the module is to understand the purpose of VLANs and how to configure VLANs. Okay, so this lesson is divided into two parts, or rather this video is divided into two parts. Part 1, we look at the purpose of VLANs in a switch network, and then we talk about VLANs in a multi-switch environment. So we start looking at VLANs in a single switch, how VLANs can be used to segment the network in a single switch, and then how VLANs operate when you start to have a number of switches all interconnected together. How do PCs connected to the same VLANs but in different switches, how do they work? How do they communicate? Okay, so we look at how switches forward frames based on the VLAN config in a multi-switch environment. And then part 2, that's when we bring up a blank packet tracer file and we start to configure switch port to be assigned to a VLAN, or we create the VLANs first, we assign the ports to the VLANs, and then we create trunk ports so that we can allow each VLAN to communicate. Okay, so this is going to be intra-VLAN. And then finally we look at the purpose of DTP. Now, lecture notes on Moodle, rather on NetAcad, the Cisco NetAcad system. So you can portal, so you can download the lecture notes and then go through as you watch this video. Okay, so first of all, VLANs are basically logical connections with other similar devices. When you place devices into various VLANs, they have several characteristics. One, each of those devices in the separate VLAN does not have any idea about what other device or where the other devices are. So this kind of forms or provides a segmentation of the various groups of devices that happen to be on the same switches. Okay, so you can have a single switch and connect a number of devices and they'll be in separate VLANs. For example, this PC is in a separate VLAN, this PC in a separate VLAN, this machine is also in a separate VLAN. Although they are connected to the same switch, they happen to be in different networks, okay, virtually. Okay, that's how we get the term virtual local area network. So this has a number of benefits, or this results in a number of benefits. You will notice that it gives the organization or creates the network to be more manageable, provides organization that is more manageable. Broadcasts are contained within one VLAN, so VLAN 2 devices will only receive broadcasts that are circulated within VLAN 2. Broadcasts sent out to VLAN 2 do not propagate into VLAN 3 or VLAN 4. Each VLAN will have its own unique range of IP addressing. Okay, when you send a unicast or multicast, they are also isolated within every individual VLAN. Now, VLANs create a way in which we can be able to manage the network. Remember that the legacy switch networks, they were flat topologies, meaning switches were just connected one after the other, and by design, switches usually forward out broadcasts to all other ports except from where it came from. So if a switch forwards out a broadcast to other ports, that broadcast might go to another switch, and then the switch will do the same, it will broadcast it out. So you keep having switches for the broadcast messages, and you end up having broadcasts sent throughout the entire network. Okay, so remember that we learned about two devices. One is the router and one is the switch in our last lesson, and we learned that the router separates broadcast domains. Switches create collision domains. Unless you have full duplex, you eliminate the collision domain. But the only device that separates broadcast domains is a router. But here, what the point I'm trying to bring across to you here is that you can do that without a router. You can use a VLAN to really separate broadcast domains. So you see, you have one broadcast domain here, that's VLAN 2. You have another broadcast domain, VLAN 3. You have another separate broadcast domain, VLAN 4. So each VLAN creates its own broadcast domain. it segments the whole entire network into a smaller network through the use of VLANs. Okay, so VLANs play a very important role in a network. Now, there are several benefits of VLANs. When we use VLANs, we have smaller broadcast domains, so we are able to divide the LAN, reducing the number of broadcast domains. It improves security. Only users within the same VLAN are able to communicate together. Another thing is that there's improved IT efficiency. With the use of VLANs, we are able to group devices with similar requirements. They can be grouped either based on functional departments like faculty, student, guest, sales, HR, ICT. You can create VLANs based on functional departments or functional divisions, or you can create VLANs based on application requirements. Another benefit that VLANs bring about is reduced cost. You don't need to have or purchase a router every time you want to create smaller broadcast domains. You can just use VLANs. The use of VLANs also improves network performance. Smaller broadcast domains reduce traffic, and this results in improving bandwidth. Simpler management, similar groups will need similar applications and other network resources, so you can again use VLANs to segment different parts of the network based on your network requirements or based on your network needs. So these are some of the benefits that VLANs bring about or VLANs provide to a network. Okay, so once we know the different benefits of VLANs, we may want to know what are the different types of VLANs then. By default, there is always at least 5 VLANs that are listed whenever you type show VLAN brief in a router. You'll see the first VLAN is sometimes, or rather known as the default VLAN. Okay, VLAN 1, that's called the default VLAN. And then after VLAN 1, you'll see another 4 VLANs that are there also by default: FDDI default, token ring default, FDDI net, TRNet. These VLANs are for legacy, are there for legacy support, legacy technology support or backward support. These VLANs are there. Otherwise, you will notice that the VLAN that we will be mainly working with in this module is VLAN 1, which happens to be named as the default VLAN. Now the VLAN 1 or the default VLAN has several names. VLAN 1 goes by the name default VLAN. Sometimes it's also referred to as the default native VLAN. It's also the default management VLAN. Now you will recall that at one stage we were configuring a switch I think in CCNA1, and then we created a switch, and we were able to create a management VLAN, or rather use VLAN 1 as a management VLAN and assign an IP address to it. Okay, so management VLAN is intended for remote access to the device. Okay, that's the purpose of the management VLAN. Now native VLAN is used to carry untagged traffic. When traffic goes through the switch and the switch does not identify any VLAN tagged information, what the switch usually does is it will drop all those packets, untagged traffic, into the native VLAN. Okay, so VLAN 1 is the default VLAN. It's also seen as the default native VLAN. It's also seen as the management VLAN. Practice is that we do not use VLAN 1 as the native VLAN nor as the management VLAN. Okay, best practice, Cisco recommends that best practice, we use a separate VLAN and leave VLAN 1 as it is. And also another thing to note, that you cannot delete VLAN 1. Okay, VLAN 1 is a default VLAN. By default, all ports are part of VLAN 1. Okay, all the switch ports, they all by default part of VLAN 1, and you can't delete VLAN 1. However, Cisco recommends that we assign these default features to other VLANs other than VLAN 1. Okay, so apart from those existing default VLANs, we would usually create VLANs based on their functionality and based on what we would want to achieve or configure out of that VLAN, our network requirements again. So for example, we could have a data VLAN that's basically dedicated to all user generated traffic like emails, web traffic, this could be specified for those type of traffic. So VLAN 1 being the default VLAN, we leave it as it is, but we create a separate VLAN called the data VLAN, and this VLAN will be specifically for user generated traffic. And then you have a native VLAN. Again, notice native VLAN used for trunk links only, and all frames that are tagged on an 802.1q trunk link, except for those on the native VLAN, they'll be sent to the native VLAN. Okay, so native VLAN, again, we should not be using VLAN 1. This is used for trunk links only. Any untagged traffic will go to the native VLAN. So again, native VLAN, don't use VLAN 1. Management VLAN, again, by default, VLAN 1 is the management VLAN, but it's best we always create a separate VLAN to be used as a management VLAN. And management VLAN is typically used for SSH and telnet traffic, and should not be carried with any end user or user generated traffic. Okay, this is for management purposes only. Okay, so typically management VLAN, we will usually assign an IP address. Okay, it's an SVI, so we'll assign an IP address for us to access the VLAN from anywhere on the network. And then there's another VLAN that we would want to create, which is the voice VLAN. Again, this is a separate VLAN required because voice traffic has several characteristics. It requires an assured bandwidth, high quality of service priority, its ability to avoid congestion. So we need to separate data traffic from voice traffic, keep them separate. Otherwise, when you start to have phone calls coming in, you may not be able to have the calls successful because they are mixed in the same VLAN. Voice traffic requires that there must be a delay that is less than 150 milliseconds from source to destination. So I think by looking at this, you can tell that voice traffic is very sensitive, so it needs to be in its own separate VLAN. So when you're designing a network, you must design it in a way that will also support not just data traffic, it will also support voice traffic as well. Okay, so here's an example given here. You have a router here, the router connected to switch 1 connected to switch 3, and then you have an IP phone and a PC. So you will notice that switch 1 has been configured to support voice traffic, so it uses VLAN 150. We realize that VLAN 150 is a general rule that is used in practice in designing VLANs. 150 is assigned to voice VLANs. Okay, so notice it uses VLAN 150 for voice VLAN here, and switch 1 prioritizes voice traffic. Okay, so prioritizing meaning there's a traffic priority place, a class of service is defined on the VLAN, so that any time it sees voice traffic, it will give priority to that type of traffic. Okay, so the second part of this lesson, before we look at that, again, just a recap on what we have just talked about so far. VLANs are very important. VLANs segment a network. VLANs basically improve performance in a network. VLANs are able to help you manage a network by way of grouping functional devices or devices that have similar requirements, application needs. You're able to place them into groups through the use of VLANs. And also we saw that VLANs also help provide some layer of security and reduces broadcast domain. And then we learned that there are several types of VLANs that we can create, but by default there's always VLAN 1, and then you have the other VLANs that are there for legacy support. But VLAN 1 is sometimes referred to as the native VLAN, management VLAN, default native VLAN, default management VLAN, and it's also the default VLAN. So you can't delete VLAN 1, but best practice is to use different numbers for those VLANs mentioned. We can have data VLAN also, we can have voice VLAN also. Okay, so the second part of this lesson, we now look at VLANs in a multi-switch environment. Now, so far you would already see that when you create VLANs in a single switch, we are able to segregate traffic by way of creating separate VLANs. So for example, VLAN 30 is for guest, 20 is for student, faculty is for VLAN 10 is for faculty. Okay, so in that way, PCs in VLAN 20 will only be able to see each other. They can't see VLAN 10, they can't see PCs in VLAN 30. And that's in a single switch. What if we expand that network and we add switch 1 and switch 3? And then we end up with the same VLAN on switch 3. So we have 10 for faculty, we have 20 for student, and we have 30 for guest. We need to have intra-VLAN communication. So what I mean by that is we need to have PC1 to be able to see PC4, because they are in the same VLAN. VLAN 10, 10, faculty, faculty, same name, same VLAN number or VLAN ID. Likewise, PC2 and 5 should be able to see each other. 3 and 6 should be able to see each other. This is where the next concept comes in, trunks. Okay, so you need trunk ports. So a trunk link or a trunk port is a point-to-point link or a point-to-point a port between two switches. Okay, so you see here I'm highlighting them. Between switch 2 and switch 1, port 1 and port 1, port 1, that's a trunk link. Okay, I'll use a different color. So this is a trunk link, this is also a trunk link. Okay, so why is it a trunk link? This one single link is going to carry 3 VLANs. It will carry VLAN 10 traffic, it will carry VLAN 20 traffic, it will also carry VLAN 30 traffic. Okay, so it's like a pipe put across from switch 2 to switch 1, okay, carrying 3 types of VLANs. Okay? And same thing on this side as well, so between switch 1 and switch 3. Okay, so trunk functions are important. They allow more than one VLAN to be able to communicate with each other. Not inter-VLAN, not VLAN 10 trying to communicate with 20. No, 10 and 10 communicating, but in multiple switches. They give us the ability to extend the VLAN across the entire network, again across multiple switches, and by default, trunking supports all VLANs, and it also supports 802.1q trunking. That's the protocol that is used to tag. Okay, 802.1q is the protocol used to tag every VLAN traffic. So we'll see this later in the next couple of slides. Okay, again, trunking very important, and remember that it's a point-to-point link, meaning that our trunk link between switch 1 and switch 2 is just between switch 1 and 2. It does not cater to the link between switch 1 and 3. So we have to create another trunk between 1 and 3. Okay, that will allow PC1 to be able to communicate with 4, 2 to communicate with 5, 3 to communicate with PC6, and so on. Okay, so again, trunking is important. Okay, trunking is important. By now you would already see this. For example, let's take this network for example and see what if this network was without VLANs. Okay, I mentioned this earlier. If PC4 sends a broadcast to switch 3, you know what switch 3 will do? It will forward it through this interface, it will forward it here, it will forward it here, except going back, it will not. That broadcast goes to switch 3, switch 3 forwards it, okay, goes to 2, 2 forwards it, that way, and that way. You see, so every time a broadcast is sent, switches just propagate it, they forward it to all other interfaces, active interfaces, except from where the broadcast came from. And any unknown multicast, unicast is also forwarded out to all other interfaces. So this creates problems. Okay, it reduces network performance in the network, because now you end up with a lot of broadcasts being propagated out throughout the entire network. Okay, so when we create VLANs, what we are really doing now here is we are reducing the broadcast domain. So if PC4 were to send a broadcast out, that broadcast will only go here, 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 and up to 1, okay, because they happen to be in the same VLAN. If PC2 sent a broadcast out, it will only go to PC5 because they are in the same VLAN. Okay, so VLANs reduce the broadcast size, okay, the size of the broadcast domain by creating smaller broadcasts per VLAN being created. Okay, so broadcasts are not propagated out to other VLANs, and so that also means inter-VLAN communication is not going to happen unless there's some form of layer 3 functionality or routing done here. Okay, so the next question you may want to ask is, if PC1 sends a message down to internet to go to PC4, which is also in the same VLAN, how does switch 1 and 2, switch 2 and 1 and 3 know where to forward the traffic to? It's all to do with what's called tagging. Okay, we are able to, or switches are able to identify each VLANs with the tagging information that's contained within the frames. And the protocol that is used to do that is the IEEE 802.1q protocol. Okay, so notice the header is 4 bytes. Okay, the tagging header is 4 bytes, and it's placed right in between the source MAC address and the type and length of the frame field. Right in between there, it's placed there. Now notice that 4 bytes field or header contains all this information. Okay, or rather this, I'm pointing to the wrong, the tag contains all this information. Okay, so this is the original fields of the frame. You have the destination MAC address, the source MAC address, the payload, FCS, you have the type of the frame, and then you have the tag added in. Okay, so again, remember, this tagging is important because every frame, when it goes to the switch examines the frame. So when the frame arrives at the switch will open up the frame, and then it will take a look at this. Okay, so then it will know, based on the VLAN ID, it knows it belongs to VLAN 10 or 20 or 30 or whatever VLAN is created. That's where the switch begins to know where to forward it to. PRI tells it the priority, the user priority of that VLAN tag field. The first field is the type field. This is sometimes referred to as the tag protocol ID or TPID, and then you have the canonical format identifier. Now this is just for support, placed here for supporting token ring frames on Ethernet. And then you have the VLAN ID, which is an important part of what we are trying to understand here. This VLAN ID in fact helps the switch know where to forward every frame to based on the VLAN ID. Okay, so tagging is important. Okay, tagging is important. The tagging allows the switch. Remember, without this tag information, where do you think without this part, where do you think the switch is going to forward the frame to? Okay, where do you think it will forward it to? The native VLAN. Okay, remember, the native VLAN is for any untagged traffic. Okay, the switch will start forwarding them out to the native VLAN. Okay, so yep, that's what I was referring to here. Native VLANs and the 802.1q tagging. So 802.1q, or let's just say .1q trunking tagging is typically done on all VLANs, and then the use of the native VLAN was designed for legacy use, okay, like a hub, okay, where the hub does not do any tagging on traffic. So when the hub is there, it will not do any tagging. Okay, so any traffic that is not tagged, go to the native VLAN, go to the native VLAN. So again, notice, unless it's changed, VLAN 1 is the default native VLAN. Okay, so again, best practice is to change the native VLAN and use a different VLAN. And then with trunking, both ends of the trunk link must be configured with the same native VLAN. Okay, so you will notice when we start to go into the packet tracer and then we build our own network, we start to see this. If we change the VLAN and we connect the switch to another switch, it will keep giving us a message telling us that there's an inconsistency in the VLAN or VLAN mismatch, the native VLAN especially. Each trunk is configured separately, so it is possible to have different native VLANs on separate trunks. Okay, so when we're creating trunk interfaces, again, it's important to specify Okay, specify what native VLAN we are using on each of the trunks. Okay, so when we get into the packet tracer file, we start doing the configurations. We'll have a look at how this works. Okay, so like every other traffic, voice traffic also needs to be tagged, and for voice traffic in particular, switch will typically use CDP to inform the phone of the voice VLAN. Then the phone will start tagging its own voice traffic and setting a quality of class of service. So class of service, COS, it's a type of quality of service, especially for layer 2. Okay, so when we go into configuring VLANs, I'm going to add a challenge activity where you will also configure VoIP, and then I'll show you why you need to do the MLS class of service traffic prioritization here, or quality of service. The phone may or may not tag frames from the PC, okay, because sometimes you will notice that the PC is actually connected to the phone and then the phone connected to the switch. Okay, so phone may tag it, it may not tag the frames. Again, key things you need to pick up out of this part of the lesson is voice VLAN is always tagged with an appropriate layer 2 class of service priority value. For access VLANs are referring to VLANs that are access ports for data traffic and other type of traffic, and not voice. Okay, so we can specify a port to accept voice. We can also specify to accept any other traffic apart from voice. So again, access VLAN can also be tagged with layer 2 class of service, or sometimes they may not be tagged. Okay, there's no class of service placed on the VLAN. That's for access VLANs. Okay, so we can go by default all switch ports are access ports. Okay, so this is one way you can verify voice VLAN verification example. If you type show interface FA018 switch port, you'll be able to see details of the interface. So when we're doing the again, when we go into packet tracer, I'll go through each of these commands and explain what each command will show us, or what information we should be paying attention to. Okay, so that's the first part of the lesson. The next part I will be talking about VLAN config. But let's just do a recap again on what we've covered in the second lesson. We talked about VLAN tagging, VLANs in a multi-switch environment, and why it's important for trunking to be done, so that we have the same VLANs in multiple switches being able to see each other. And when the trunks are created, VLANs need to be tagged so the switches know where to forward or where the traffic is intended to go to. Just by looking at the tag field, seeing the VLAN ID. So there are several fields in the tag. There's a TIE, PRI, CFI, and VID, the VLAN ID. Okay, so the VLAN ID is an important part of the field because it identifies what VLAN the traffic belongs to. So any untagged traffic is usually sent out to the native VLAN. Okay, that's placed in there for legacy support. And then there's also voice. So again, when we're creating VLANs and we're configuring VLANs, we realize that there's voice traffic that can be carried, which needs to be tagged with appropriate class of service priority value. And then you have the access VLANs, which may or may not need any tagging of any class of service priority value. Okay, so we'll stop here. In the next the part 2 of the video, we'll look at packet tracer, and then we'll start configuring VLANs.